Welcome to the Learning Pines YouTube. We hope this video helps.
You start by verifying prerequisites, model, firmware, and interface. Connect power and ground first. Make sure the supply can deliver stable 5V at 1A or more. Once powered, attach the communication cable to the host, USB, UART, or CAN, and enable the port. Calibrate orientation by leveling the sensor within 2 degrees. This reduces systematic tilt errors. Finally, power cycle the unit to force a clean boot and confirm the device appears on your host system before proceeding to configuration. Now configure the LiDAR. Match baud rate and protocol on both sensor and host, then set scan frequency and angular resolution that suit your application. You choose higher resolution for detail but lower frequency for throughput. Once set, perform a controlled scan of a static target at a known distance to validate range accuracy and point density. Log raw point data and view filtered output. This reveals noise patterns and dropouts. If measurements drift, recheck grounding and firmware settings before adjusting filters. Finish by integrating LiDAR data into your system. Time-sync scans with odometry or IMU and apply the sensor body transform so points align in the vehicle frame. Then run calibration routines for range bias and angular offsets. These correct systematic errors and improve mapping. Validate results in motion and adjust filters for real-time use. If you encounter intermittent data loss, first check power stability and cable integrity. Unstable 5V or a loose connector is the most common root cause.
Thanks for watching. Consider subscribing if we helped you.